we continue our journey of unlocking the universe, venturing into the heart of celestial nurseries where stars are born. A star's birth is a violent yet fascinating process, a cosmic spectacle of transformation. These celestial bodies, these giant luminous spheres of plasma, are born from collapsing clouds of hydrogen and helium, the most abundant elements in the universe. Imagine, if you will, a vast, cold cloud of gas and dust floating in the emptiness of space. It's here, in these seemingly barren celestial cradles, that stars begin their lives. Over time, gravity pulls the cloud's atoms together, causing it to contract and the center to heat up. As the cloud collapses, it fragments into smaller clumps, each of which will eventually become a star. But what ignites this celestial fire? What causes these balls of gas to shine so brightly? The answer lies in the heart of stars themselves, nuclear fusion. In these extreme conditions, hydrogen atoms are squeezed together so tightly that they combine to form helium. This process, known as nuclear fusion, releases a tremendous amount of energy, causing the star to glow. This is the moment of a star's birth, when it begins to shine, converting mass into energy. But the birth of a star is just the beginning of its journey. Depending on its mass, a star can live for millions to billions of years, shining brightly in the cosmos before it eventually exhausts its nuclear fuel and meets its fate. From the chaos of collapsing cosmic clouds, a star is born, a new light in the vast cosmic tapestry. This is the birth of stars, a process as old as the universe itself, and a testament to the ever-changing nature of the cosmos. Stars, the celestial bodies that light up our night sky, are as diverse as they are numerous. Whether they're twinkling gently in the distance or blazing brightly in the night sky, each star is unique, exhibiting a range of characteristics that make it distinct. Astronomers classify stars based on their color, temperature, size, and brightness, each of which can tell us a great deal about a star's life and history. The color of a star, for example, can tell us about its temperature. Blue stars are the hottest, while red stars are the coolest. White and yellow stars, like our sun, fall somewhere in the middle. The size of a star can vary greatly too. Some stars, known as supergiants, are hundreds of times larger than our own sun. At the other end of the scale are the white dwarfs, stars that are so small they're only slightly bigger than Earth. Brightness or luminosity is another key characteristic. It's determined by a star's size and temperature. Bigger, hotter stars shine more brightly than smaller, cooler ones. Lastly, the chemical composition of a star, revealed through its spectrum, can tell us about its age and the elements it contains. From red giants to white dwarfs, each star in the cosmos has its own unique story to tell. Whether it's a young, hot star just beginning its journey, or an old, cool star nearing the end of its life, each has its own characteristics that make it unique. The factors that influence these characteristics, including a star's age and chemical composition, are crucial in understanding the life cycle of stars and the larger cosmic narrative. Understanding the characteristics of stars is not just about studying these celestial bodies themselves. It's about piecing together the larger cosmic puzzle, about understanding the processes that have shaped the universe and continue to drive its evolution. As we delve deeper into the characteristics of stars, we are unraveling the mysteries of the cosmos, one star at a time. Having explored the fascinating characteristics of stars, let's delve deeper into how astronomers classify these celestial wonders. The classification of stars is a complex process based on their diverse properties such as color, temperature, size, and brightness. This system of classification, known as the Hertzsprung-Russell diagram, helps us understand the life cycle of stars. It also aids in uncovering the mysteries of the cosmos. Stars are classified into 7 main types: O, B, A, F, G, K, and M, from hottest to coolest. O-type stars are the hottest, with temperatures exceeding 30,000 Kelvin. They are usually blue and have the highest mass and brightness. M-type stars, on the other hand, are the coolest, with temperatures below 3,500 Kelvin. They are red, have the lowest mass, and are the dimmest. Our Sun, a G-type star, falls somewhere in the middle, with a temperature around 5,500 Kelvin. Further, stars are also classified into various luminosity classes, ranging from dwarfs to supergiants. Dwarf stars, like our Sun, are relatively small and low in brightness. Supergiants, on the other hand, are the largest and brightest stars in the universe. They can be hundreds to thousands of times larger than our Sun. To make things even more interesting, there are also unique types of stars like neutron stars and white dwarfs. Neutron stars, the remnants of supernova explosions, are incredibly dense, while white dwarfs represent the final evolutionary state of stars not massive enough to become neutron stars or black holes. Understanding this classification system is like learning a new language. It allows us to read the stories of stars, their birth, life, and death. Each star, from the hottest blue giant to the coolest red dwarf, has a tale to tell. A tale written in the language of light and color, size and brightness. As we continue our journey, exploring the formation of stars after the Big Bang, remember this classification system. It will help us understand the grand narrative of the cosmos, one star at a time. In the beginning, there was the Big Bang. This cataclysmic event, which occurred nearly 14 billion years ago, gave birth to the universe as we know it. It was a moment of unimaginable energy and intense heat, an explosion of space and time that created everything we see around us. The Big Bang did not just create space and time, but also the fundamental building blocks of the universe, hydrogen and helium. As the universe rapidly expanded and cooled, these elements coalesced, forming vast clouds of gas. But what came next? How did these primordial clouds of hydrogen and helium give birth to the first stars? This is a question that has puzzled astronomers for centuries. We believe that the answer lies in the force of gravity. Over time, gravity pulled these clouds of gas together, causing them to collapse under their own weight. As the gas clumped together, it heated up, igniting the nuclear fusion process and giving birth to the first stars. These stars, often referred to as population the three stars, were unlike any we see today. They were massive, hot and short-lived, burning through their nuclear fuel at an incredible rate. These first stars played a critical role in shaping the universe. They were the creators of the heavier elements, the forgers of the cosmic metals that would later form planets and life as we know it. When these stars met their explosive ends as supernovae, they dispersed these elements throughout the cosmos, seeding future generations of stars and planets. The formation of stars after the Big Bang marked the beginning of the cosmic story we are a part of today. From the birth of the first stars to the death of the last, each event is a chapter in the grand narrative of the cosmos, a tale of transformation and change that continues to unfold. As we explore the birth, life and death of stars, we are not just studying celestial objects, we are uncovering the history of the universe itself. After the Big Bang, the universe was a hot, dense sea of particles. As it expanded and cooled, the first stars began to form. These were not the stars we see in our night sky today. These were the colossal, short-lived population 3 stars, the pioneers of stellar evolution. Over billions of years, these stars lived, died, and were reborn in a cosmic cycle of creation and destruction. As they died, they seeded the universe with the heavier elements, the building blocks for future generations of stars and planets. The birth, life, and death of these early stars had a profound impact on the universe. They were the architects of the cosmos, shaping the galaxies and the large-scale structure of the universe. Their explosive deaths as supernova sent shockwaves through the cosmos, triggering the birth of new stars and dispersing the elements necessary for life. Over time, the stars evolved. Each generation was a little different from the last, reflecting the changing conditions in the universe. The stars we see today are the descendants of these early stars, born from the dust and gas enriched by countless stellar lifetimes. And so, from the first stars born in the wake of the Big Bang to the billions that fill our night sky today, each star has a story to tell. They are the witnesses to the history of the universe, a history that is written in their light. As we unravel the life, death and rebirth of stars, we are not just looking at points of light in the night sky. We are reading the pages of a cosmic history book, uncovering the story of our universe one star at a time. Once ignited, a star embarks on a journey of life and death, dictated by its initial mass. This cosmic voyage is a symphony of transformation, full of cosmic crescendos and silent finales. To comprehend this journey, let's delve into the life cycle of stars. High-mass stars, the celestial heavyweights, lead a fast-paced life. Born from collapsing clouds of hydrogen and helium, they quickly ignite, setting the stage for a luminous performance. The nuclear fusion at their core converts mass into energy, creating a brilliant spectacle of light and heat. Yet this grandeur is short-lived. The high-mass stars' intense fusion rates exhaust their fuel quickly, leading to a dramatic demise. In a powerful explosion known as a supernova, they scatter their enriched material into the cosmos. The remnants may collapse further, birthing a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. Contrastingly, low-mass stars like red dwarfs lead a more leisurely existence. Their modest mass allows them to burn their fuel at a slower pace, granting them long lifetimes that can span billions of years. As they exhaust their hydrogen reserves, these stars cool and shrink, transitioning into white dwarfs. This phase is a quiet retreat from their previous luminosity, yet it is not the end. Over trillions of years, white dwarfs continue to cool and fade, predicted to eventually become black dwarfs. However, the universe isn't old enough for any black dwarfs to exist yet. The lives of stars, whether they are high mass or low mass, are cyclical narratives of birth, transformation, and death. Each star's journey is a unique tale, yet they all share a common theme, the conversion of mass into energy. And each death, whether it be a violent supernova or a gradual cooling, is a contribution to the cosmic cycle of matter and energy. Each star, regardless of its mass, follows a path from birth to death, contributing to the ever-changing universe. The life and death of stars is not just a celestial phenomenon, but a testament to the dynamic, evolving universe we live in. The twinkling stars in our night sky have been the subject of curiosity and study for centuries. This celestial fascination has led us on a journey of discovery as we've sought to unravel the mysteries of these distant points of light. In the past, our ancestors could only gaze at the stars and wonder, armed with nothing more than their naked eyes and boundless imagination. They charted the skies, creating constellations that reflected their cultures and beliefs. But the true nature of stars remained a tantalizing enigma. As time passed, the invention of the telescope in the early 17th century marked a significant leap forward in our understanding of the stars. For the first time, astronomers could peer deeper into the cosmos, observing stars in greater detail than ever before. Suddenly, a universe filled with countless stars, galaxies, and nebulae unfolded before their eyes. The 20th century brought another revolution in star study with the advent of spectroscopy. This ingenious technique allowed astronomers to dissect starlight into its constituent colors, revealing hidden information about a star's temperature, composition, and movement. It was as if the stars themselves had begun to whisper their secrets to us. In the latter part of the 20th century, the rise of space-based observatories like Hubble, Chandra, and Spitzer extended our sight even further. By observing stars in various wavelengths, from radio waves to X-rays, we've been able to paint a more complete picture of these celestial bodies. These advancements have not only deepened our understanding of stars, but have also ignited new questions. How do stars form? What happens when they die? Do they harbor planets like our own? Every answer seems to lead us to a new mystery, a new puzzle to solve in the grand cosmic story. Our understanding of stars has been shaped by a myriad of technological advancements, each revealing a new layer in the grand cosmic story. As we stand on the cusp of a new era of star study, one can only wonder what astonishing discoveries await us in the depths of the cosmos. Stars, though countless and distant, have been named and categorized by us, reflecting our desire to understand the universe. From the dawn of civilization, our ancestors have been looking up to the night sky, identifying patterns and structures among the twinkling lights. These patterns, later known as constellations, have played a pivotal role in the naming of stars. The constellations, each with its unique shape and story, have been named after characters from ancient mythology, animals, or objects. These names, steeped in cultural influences, have been passed down through generations, creating a cosmic tapestry of tales and legends. The constellation Orion, named after a hunter from Greek mythology, or Ursa Major, the Great Bear, are but a few examples of this fascinating celestial nomenclature. Stars within these constellations have been named accordingly, often reflecting the story or the character that the constellation represents. For instance, Betelgeuse, the bright red star in Orion, translates to the armpit of the giant, a nod to the mythological hunter himself. However, as our knowledge of the cosmos expanded, so did the need for a more systematic approach to star naming. This led to the inception of designations such as the Bayer and Flamsteed systems, which name stars based on their position within a constellation or their celestial coordinates. While these names may lack the poetic charm of their mythological counterparts, they provide astronomers with a practical way to catalogue and study countless stars. But whether a star is named after a Greek hero, an animal, or assigned a set of numbers and letters, each name serves as a link between mankind and the cosmos. It's a testament to our innate curiosity, our yearning to connect with the vast universe that surrounds us. Each star, named or unnamed, is a part of the cosmic narrative, a tale that we continue to unravel. In the vast universe, our Milky Way galaxy alone is home to billions of these luminous spheres of plasma. Stars, distant suns, each one a spectacle of light and energy, a unique story told in the language of cosmos. Consider for a moment the sheer scale of our universe. If we were to count each star in the Milky Way, it would take us thousands of years. Yet the Milky Way is but one of the billions of galaxies that paint the cosmic canvas. Each galaxy, a whirl of stars, gas and dust, bound together by the invisible threads of gravity. Across this vast expanse, astronomers have made a remarkable discovery. Hundreds of these stars, distant suns, are not solitary. They are orbited by planets, some small and rocky, others large and gaseous. These celestial bodies, much like our own solar system, dance to the rhythm of the cosmos, a ballet of gravity and motion. It's a reminder that our sun, our Earth, is not unique. Across the universe, there may be countless worlds bathed in the light of their own stars. Imagine the possibilities these worlds could hold. Could they harbor life? Could they tell us more about our own origins? As we continue to explore, each discovery opens new chapters in our understanding of the universe. Each star we study, each planet we discover, brings new questions and new possibilities. It's a journey of exploration, of curiosity, of wonder. As we unlock the secrets of these celestial bodies, we come one step closer to understanding the universe, our home among the stars. Let's delve deeper into the fascinating structure of stars, the celestial bodies that light up our night sky and form the backbone of our cosmos. Just like an onion, stars have several layers, each playing a unique role in the star's life cycle and function. At the heart of every star, we find the core. This is where all the magic happens. The core is the engine room of a star, the site of nuclear fusion. Here, under extreme pressure and temperature, hydrogen atoms combine to form helium in a process called nuclear fusion, releasing a tremendous amount of energy in the form of light and heat. From the core, we move to the radiative and convective zones. The radiative zone surrounds the core, and it's where energy produced by nuclear fusion is carried outward as electromagnetic radiation. Beyond that lies the convective zone, where energy is transported by moving masses of gas in a process known as convection. It's much like the boiling of water in a pot, where hot water rises and cooler water sinks. Now let's move to the outer layers of a star, the parts visible to us. First, there's the photosphere, the star's surface that emits the light we can see. Above that lies the chromosphere, a layer that is usually invisible but can be seen during total solar eclipses as a reddish rim. Finally, there's the corona, the outermost part of the star's atmosphere, visible during solar eclipses as a beautiful shimmering halo. Understanding the structure of stars is key to unraveling the mysteries of these celestial wonders. Each layer, each process happening inside a star tells us more about its life cycle, its past, and its eventual fate. As we continue our cosmic journey, remember that each star in the night sky, each point of light, is a complex, radiant structure, a testament to the intricate and awe-inspiring beauty of our universe. Wow, what a journey it's been! We've delved into the heart of stars. We've seen how they're born, live and die, and we've even learned how they are named. But our journey through the cosmos is far from over. We hope you've enjoyed this cosmic journey as much as we've enjoyed guiding you through it. The universe is a vast, complex and endlessly fascinating place. And there's always more to discover. We're curious, what was your favorite part of our star exploration? Do you have any questions about the life and structure of stars? Please do share your thoughts, questions, or even your favorite star facts in the comments below. We love hearing from you, our fellow space enthusiasts. If you haven't done so already, do remember to subscribe to our channel for more fascinating journeys into the cosmos. From the mysteries of black holes to the wonders of galaxies, we've got so much more to share with you. So, join us as we continue to unlock the mysteries of the universe one star at a time. Until our next cosmic journey, keep looking up and keep wondering. Remember, every star has a story, and we're here to help you discover it.